Hello, so today the task given to me is to talk about photodiode. So photodiode basically is a PN junction or pin semiconductor device that consumes light energy which generate electric current. So it is also sometimes referred as photodetector, photosensor or light detector. The construction of and working of photodiode is similar to the PN junction diode. Yeah, the pin structure, the pin by the way, pin PIN is equals to is the P stands for P type, I stands for intrinsic, and N type is for N. So the pin structure is mostly used for constructing photodiode instead of PN junction structure because pin structure provide fast response time. Pin photodiode also mostly used in high-speed applications. In a normal PN junction diode, voltage is used as the energy source to generate electric current. This one, electric current. Whereas photodiodes, both voltage and light is used as an energy source to generate electric current. That's all for the photodiode. So I'm going to show you how it actually works. Sorry. So this is a basic diagram for photodiode. So photodiode is specially designed to operate in reverse bias condition. Reverse bias means that the P side of the photodiode is connected to the negative terminal of the battery, and the N side is connected to the positive terminal of the battery. So when the incident protons enter, so this is the cycle of the photodiode, PN junction photodiode.
So Assalamualaikum, my name is Akmal and I'm going to present about photodiode basic structure, material and symbol of the device. So we start with photodiode symbol. So this is the photodiode symbol. As you can see, it's just look like the usual diode symbol, but with the arrow striking the diode, the arrow represent the light or the protons. So we move to the types of photodiode. So basically the photodiode is divided into 4 types, which is PN junction, avalanche photodiodes, PIN photodiodes and Schottky photodiode. We're gonna go one by one. So firstly we start with PN junction. So PN junction photodiode, as we can see here, I put here the PN junctions diagram. So this is the simplest form that has been used from the beginning, but for today the PN junction photodiode has been developed and this kind of photodiode are no longer being used, but it's only function for low frequency and low sensitive application. Okay, move to the next, which is avalanche photodiode. So as we can see here, the avalanche photodiode is used where light has low intensity. So the avalanche photodiode provide high level of gain, but it's also produce high level of noise. So there's a diagram of avalanche photodiode. So next we move to the PIN photodiode. So the PIN photodiode, the PIN represent the regions contained in the photodiode. So this photodiode is currently used in many applications. So as we can see here, this PIN junction collect the photons of light more efficiently than the PN junction photodiode, the one before. So next we move to the Schottky photodiode, which is the last one. The Schottky photodiode is used for high frequency switching, and this type of diode has high speed capability. It's offer lower capacitance and high bandwidth of communication system. So this is the logo that you being used casually. So that's, I think that is all for the types of photodiode. So we go to photodiode material. So basically in this slide there's 4 types of material with different wavelength sensitivity. So the wavelength sensitivity occur because only photon with the sufficient energy to excite the electron across the band or gap of material will produce the current needed to develop from the photodiode. So you can see here there's germanium, indium, gallium arsenide, lead sulfide and silicon. All of them are with different wavelength sensitivity, and the highest is for the lead sulfide. So the avalanche photodiode material, so there's germanium, silicon and indium gallium arsenide. So you can read here the properties for each material. So next we're gonna go to the photodiode structure. So this is basically the structure of the PIN and PN photodiode structure. Okay, in the photodiode fabrication process, I think intrinsic, okay, just seems like others diode that we have learned before. There's a dope layer. The difference is just if it's thick, intrinsic or very lightly doped. Okay, this is to ensure the maximum amount of light reach the intrinsic layer. Electrical contacts are placed at the side of the device as shown in the slide. So okay, so next we go to PIN photodiode heterojunction structure. So this form of structure has the additional flexibility that light can be received from the substrate, and this has a larger energy gap which make it transparent to light. So for this type of structure photodiode, okay, as we can see here, it's used less standard technology, often used material such as the INGAAS and the INP depicted in the diagram. So the technology used in this structure make it expensive from the others. So this is unusually used in the industry, and there's a avalanche photodiode structure. So relatively similar to the more commonly used of PN photodiode structure or the structure of the PIN photodiode. Okay, however, as the avalanche photodiode is operated under a high level of reverse bias, a guard ring is placed around the perimeter of the diode junction to prevent the surface breakdown mechanism. So
Assalamualaikum and hi to everyone who watching this video. In this video, I like to share more about photodiode, which is more about its characteristics. Before that, I want to tell 3 operational modes in photodiode. Okay, first of all, I want to introduce one of these 3 operational mode of photodiode. First, photovoltaic mode. This mode is also known as zero bias mode. And this mode is preferred in that application where are using at low level frequency as well as ultra low level light. And this mode provide very low level current variation and produce non-linear behavior in photon conduction. For second mode, photoconductive mode, this mode, the photodiode is used in reverse bias. When photodiode is used in this mode, then the length of depletion region is increase. But the capacitance of the junction and response time is go to decrease. In this mode, current increase linearly with increase the incidence of light, and it is very fast but display an electronic noise. For the last method, avalanche diode mode, this mode is used in high reverse bias, and its work in avalanche breakdown regions. And in this mode, the internal gain and responsivity of the device has been increased. Last part, I want to draw the VI characteristic graph, and the graph is at horizontal parts, reverse voltage, unit voltage, and the vertical part, reverse current in milliamps, and the first line it's called lambda. Second line with 1 milliampere per meter square. Two milliampere per meter square. 3 milliampere per meter square. And this can call dark current. As shown is the figure, when there is no light, the reverse bias of photodiode carries in very small current and called dark current. And it is purely due to thermal generated minority carriers when the light is allowed to fall on PN junction.
Hello, my name is Ganesh. Now I'm going to explain about a photodiode's principle of operation. As you have been told before, this is a symbol of a photodiode. It can be simplified to this, in which this is a p-type semiconductor and this is an intrinsic semiconductor, while this is an n-type semiconductor. Together, this forms a PN junction. When the PN junction is illuminated with light, it causes the formation of free electrons and free holes in the intrinsic semiconductor, which causes a flow of current. This current is known as photocurrent, and this photocurrent is directly proportional to the rate of optical flux. From this, we can get the equation which is this, in which the eta for germanium is 1, while for silicon is 2. Vt is voltage equivalent of temperature, while Is is the short circuit current proportional to light intensity, and I0 is the reverse saturation current of a diode. V is positive for forward bias and negative for reverse bias. A photodiode may go through two types of photo excitation, which are intrinsic excitation and extrinsic excitation. Intrinsic excitation occurs when an electron in valence band is excited by a higher energy photon to conduction band, while extrinsic excitation occurs when a photon excites an electron in donor level to conduction band, or a valence band electron go into acceptor state. The minimum energy of a light required for the photon generation due to intrinsic excitation is the forbidden gap. And the forbidden gap is the gap located between conduction band and valence band. And each forbidden gap requires a specific wavelength of light to be exceeded, which is given by this equation. lambda equals to 1.24 divided by energy of the forbidden gap. Now we are going to discuss about responsivity, quantum of efficiency, and dark current of a photodiode. Responsivity is defined as the ratio of photo-generated current to incident light, and which is given by this equation, in which Is is the photocurrent. And quantum of efficiency is defined as a fraction of incident photon contributing to photon current, which is given by this equation, in which Ne is the number of generated carriers per unit time, while Np is the number of incident photons per unit time. From these two equations, we can use to find the dark current. By relating these two equations, we get these two equations, in which Q is the quantum of efficiency, R is the responsivity, H is the Planck's constant, V is the frequency of incident photon, Is is the photon generated current, and Pin is the incident optical power. And hence, from this we can form this equation, which can be used to find the dark current, as dark current is produced without the presence of light rays.
So the application of photodiodes involved in similar applications of photodetectors like charge coupled devices, photoconductors, and photomultiplier tubes. These diodes are used in consumer electronic devices such as smoke detectors, compact displays, and televisions, and also remote controls in VCRs. Example of smoke detector, this is the one, the principle. So the infrared beam detects the smoke particles which enters and goes to the photodiode, and the smoke detector will trigger. Then coming back to the application, other consumer devices like clock, radio, camera light meter, street lights, photoconductors are most frequently used rather than photodiodes. Besides that, photodiodes are frequently used for exact measurement of intensity of light in science and industry. Generally, they have an enhanced, more linear response than photoconductors. Besides that, photodiodes are also widely used in numerous medical applications like instruments to analyze samples, blood gas monitors, and also not stated there, but they are detectors for computer tomography, detectors for computed tomography. So these diodes are much faster and more complex than normal PN junction diodes, and hence are frequently used for lighting regulation and in optical communication. That's all for the application.